and welcome everyone. Thank you. I'm Michael Floyd. I'm head of sustainability solutions at AWS, and it's my job to prioritize, curate, publish, and help scale best-in-class solutions to our customers' most challenging sustainability imperatives. I'll be joined today by my co-presenter, Blake Blackwell, the lead architect at Persephone. It's also Blake's birthday today, so thank you to his family for letting him be here with us. We're excited to talk to you about a topic near and dear to us, which is scaling global carbon footprint management. So first, a quick flyover of the agenda. I'm going to start out with an introduction to sustainability at Amazon and AWS, followed by an introduction to carbon accounting, where it fits in, a little background on what it takes to get it done, why it's important, why it's hard. Then I'll talk about AWS's work with startups like Persephone and why they're so important. Then I'll hand it off to Blake, who will provide an introduction to Persephone's offering. He'll talk about some of the pain points they've encountered on their journey to scale, their transition from monolith to a microservices architecture, deploying their carbon management accounting platform at a global scale, a bit about their roadmap, and throughout you'll hear from Blake about the benefits Persephone as a startup has seen from building on and partnering with AWS. I'll start with the climate change. The climate pledge. Amazon co-founded the Climate Pledge with Global Optimism in 2019 to build a cross-sector community of companies, organizations, individuals, and partners working together to address the climate crisis and solve the challenges of decarbonizing our economy. The Climate Pledge is a commitment to reach net zero carbon emissions by 2040, 10 years ahead of the Paris Agreement. Scientists tell us that we have a limited window in which to make unprecedented headway in order to limit global warming to 1.5 degrees Celsius above pre-industrial levels by 2050. No one company or organization can do this on its own. Everyone must do their part. Business does not operate in a vacuum. So to drive collective cross-sector action on the climate crisis, Amazon co-founded the Climate Pledge based on the conviction that global businesses are responsible, accountable, and able to act on the climate crisis. The Climate Pledge itself is open to all companies who want to commit to achieving net zero carbon by 2040. The three principles for others to join are regular reporting, carbon elimination, and credible offsets. Amazon's own public stated commitments in line with the Climate Pledge are to be net zero carbon emissions by 2040, and to power our operations with 100% renewable energy, which we initially committed to achieve by 2030, but are now on a path to meet by 2025. And I love this quote from Hurst, Amazon's VP of Sustainability. To create a lasting and systemic change on our planet, we are focused on driving change beyond Amazon and in partnership with others. That's why we co-founded the Climate Pledge and created the Climate Pledge Fund. We cannot go this alone, nor would we want to. So if there's one thing that I want you to take away from this presentation, it's the power of the network effect that AWS can have with our partners, including startups, to enable our customers to go further, faster on their sustainability journeys. Today, over 375 organizations across the world have taken the Climate Pledge. And as of September 2022, the Climate Pledge signatories are in 34 countries, representing 54 industries. And I'm excited to share that our co-presenter today, Persephone, recently became a signatory to the Climate Pledge as well. Persephone is a climate disclosure and carbon management solution. Their climate management and accounting platform enables companies and financial institutions to more easily meet stakeholder and regulatory climate disclosure requirements and requests. I'll talk about what it takes to do carbon accounting shortly, why it matters, why it's hard. But for now, let me submit to you that startups those building sustainability offerings on AWS are crucial to tackling climate change. When they build on AWS, they're not only building on a sustainable cloud infrastructure, but even more importantly, they're developing those essential technologies needed for decarbonization at scale and across sectors. Why does this matter? Well, fundamentally, it goes back to the old adage, what gets measured gets managed. When we start to track emissions, this is the first step towards decarbonization. Once we know where the emission sources are, we can address them. For this and other reasons, climate tech is really blowing up. Organizations worldwide are setting ambitious emissions targets and are looking for better ways to measure and manage their carbon footprints. Organizations need to baseline, track, and improve transparency. These are all critical steps towards decarbonizing the global economy. And if we look back at the 3 principles of the climate pledge, regular reporting, carbon elimination, credible offsets, it's solutions like Persephone's that simplify and accelerate reporting, help companies to validate or refine their climate strategies to reduce footprints, and provide a clear picture of the remaining emissions to be offset. And of course, this is important not just through the lens of the climate pledge. Companies today face a raft of complex, evolving influences and obligations, starting with the global goals and principles as defined by the UN, by the Paris Climate Accord, the Greenhouse Gas Protocol, and others, which serve as a common foundation. We've also seen a proliferation of reporting frameworks, helping organizations to more consistently quantify and qualify their performance and progress towards sustainability targets. Then we have emerging and in-force regulations, requiring measurement and disclosures, often aligned to some of those frameworks. Finally, we have ESG ratings and tools made available by data providers as a mechanism to compare corporate sustainability performance, inform decision-making when it comes to, for example, ESG investment or choosing sustainable suppliers in procurement. So, how does one do carbon accounting and reporting? Let's look at what the emission sources are, and I'm going to provide a kind of simplified flyover here. In carbon accounting, greenhouse gas emissions are divided into 3 scopes according to the Greenhouse Gas Protocol. Scope 1 includes direct emissions from owned or controlled sources, such as fuel burned in a boiler at my plant or diesel burned by my fleet of trucks. This is not too hard. Just look at your fuel burn, you'll find a number. Scope 2 emissions include indirect emissions from the generation of purchased energy consumed by the reporting company. Usually electricity from the grid, but this can also include, for example, purchased heat or steam. Usually we have a number here too. Just refer to your energy bill. Scope 3 is where things get tricky. These are emissions from your value chain not covered by scopes 1 and 2. So upstream, we have categories like purchased goods and services, your supply chain, capital goods, fuel and energy-related activities, leased assets, operational waste, business travel, employee commuting. And downstream, we have categories like transportation and distribution, processing of sold products, use of sold products, think automobiles, airplanes, industrial equipment, electronics, things that consume energy. Product end-of-life treatment, how do we recover, refurbish, recycle, or landfill end-of-life products? What are the impacts there? Investments, downstream leased assets, and franchises. You see how this starts to get complicated. So, with that understanding of scopes and categories of emissions, how well are we doing at accounting for them? Well, late last year, Boston Consulting Group published the results of a survey of executives at over 1,200 organizations across 9 major industries about their ability to measure and manage emissions. The survey found that companies are failing to measure their emissions exhaustively. 81% of respondents don't report all their internal emissions. Think back to scope 1 and 2 from the previous slide. And 66% don't report any of their external emissions. Think of those scope 3 emissions related to the company's broader value chain. Again, that part is hard. Scope 3 is really tricky to measure. The required data is limited, tends to be tough to unify. It's usually siloed, incomplete, of inconsistent quality. The boundaries of what gets measured and the methodologies for calculating scope 3 emissions may vary. So most organizations struggle here to account for the full carbon footprint of their products and services. We also see a problem with accuracy. Respondents report an average estimated error rate of 30 to 40% in measuring their emissions. Lastly, carbon footprint accounting has long been a time-consuming and manual process. 86% of companies are still using spreadsheets to pull together fragmented, often out-of-date data, often coming from legacy management systems. A minority have managed to automate the gathering of their emissions data, but not many. So where does this leave us? Well, in the current state, the exercise of carbon accounting often leads to a once per year, after the fact, point-in-time snapshot of performance. This is annual reporting. And as you can imagine, it's hard to plan your decarbonization roadmap based on annual reporting alone, without the benefit of more dynamic data collection and up-to-date insights. The point here is, organizations need better solutions for carbon footprint management, and they need them quickly. When you look at the complexity and urgency of the problem, it makes the work of startups like Persephone all the more crucial. So let me spend a moment on startups, which are helping with a lot of solutions in the domain of sustainability. And here are some examples. I submit to you that startups, like those building sustainability offerings on AWS, are crucial to tackling climate change. They're developing the essential technologies needed for decarbonization at speed and at scale. If we think back to that quote from Hurst and the importance of network effects, startups are in a great position to answer rapidly evolving sustainability challenges at the speed of business. So Persephone is in good company. There are a multitude of startups building on AWS, already creating products, services, and tooling that lead to more sustainable practices across a wide array of industries. Some of them you might already know, others might be new to you. Why are they doing this? Why are they tackling these challenges on AWS? Well, it turns out AWS helps them as well. So I'll take a minute to walk through why startups tend to want to build on AWS, touching on the main challenges they face and how they overcome them. First, startups have to be agile. We love startups because they disrupt and transform industries. They reshape how we live, making our lives easier with the types of products and services they produce. Most importantly, they do this quickly. And again, in the global decarbonization effort, speed and transformation are key. Secondly, startups need the right tool for the right job to move quickly. AWS has over 200 services and counting. By the time reInvent is over, this number will have grown. The pace of innovation here is jaw-dropping. And that's because customers set our course and truly define what we build at AWS. Our roadmap is 90% customer-led. The range of technology options runs the gamut, from storage to compute, AI, ML, IoT, data and analytics. We are building at the edge of what's possible, and that suits the startup DNA, where the bleeding edge is the primary option. Thirdly, startups need to ensure they're running efficiently across their organizations. They need to be built lean. If you look at most companies' on-premises infrastructure management, to get even a server typically takes 10, 12 weeks. In the cloud, you can provision thousands of servers in minutes. You can get a POC up and running in weeks. You can access over 200 services that you do not have to personally build and maintain. You can put them together to best fit your business needs, and this gets you from the fail-fast stage to implementation on a completely different timescale than otherwise would be possible. Finally, startups need global infrastructure to scale. Taking Persephone as an example here, They grew their emissions under management in just 3 years to a volume equivalent to the energy emissions from over 900 million US homes. There are not 900 million US homes, let's be clear. This is a huge number. So to wrap it up, the cloud is the best place to build and scale sustainability solutions at the pace of urgency required of us. Impact equals solution times scale. And Persephone are a great example of what's possible here. In just a minute, I'll get out of the way and hand it over to Blake, who's going to talk about what they're doing to make a real impact. But I'll close with this. For all you sustainability startups out there, as you listen to Blake's presentation, I want you to look at Persephone as a model of success. See how they've scaled. We want the world's best sustainability startups building with us. And this is what's behind our partnership and our collaboration. Thank you. Blake, over to you.
All right. We practiced that. All right, well, thank you, Michael, appreciate that. All right, well, so first off, just let me start by introducing myself. My name is Blake Blackwell, and as Michael mentioned, I lead the product architecture team at Persephone, which really helps design and build our platform for that scale that he was talking about. Before coming to Persephone, I actually worked at AWS as a senior solution architect. And this really gave me some insight into both the Persephone or Amazon's focus on climate, as well as how to best leverage their technologies and to leverage their technology teams to build the product that we're currently building today. You know, at Persephone, we really focus and take a lot of pride in terms of our user experience and our beautiful product that we're creating. But underneath the hood, there is always the architecture and the scale and the complexity of solving these types of things for a global base. So that's where my team really comes in, and we build these things to handle this kind of complexity that's there. I've actually been with the company going close to 2 years now, and in startup life, that is a near eternity. You age quite quickly in the startup world. As Persephone was getting started, we realized that we had multiple options in the cloud. And once Amazon presented their climate mission, we realized it was very aligned to our own. And we stand with Amazon and other signatories of the Climate Pledge, and we're very proud to be a signatory with them. We are committed as a company to being net zero by 2040 across scopes 1, 2, and 3. 10 years ahead of the Paris Agreement. And by joining this climate pledge, we are reinforcing our commitment to sustainability, and we're really excited to join a community that will share knowledge, ideas, and best practices with people like yourselves in this room. We look forward to working alongside all of you on this important mission. Now, not only are AWS and Persephone's missions aligned from the climate perspective, but AWS really does help startups build through things like the AWS Marketplace and empowering technology teams like my own with tight collaboration through things like AWS Data Labs. And we'll talk about that here in a few moments. Like AWS, we're a company of builders, and we really enjoy working with their strong technology teams of builders as well. So Michael's already referred to kind of the complexity, the regulations, the challenges of actually getting carbon managed and all that. But I want to walk you through Persephone's approach to how our platform as a climate management accounting platform actually facilitates this. So it is much like a classic data application where on your left, we simplify getting data defined and into our platform. So if you look over to the left, the first thing that we have to do is, as Michael mentioned, there's all scope 1, 2, and 3, but those types of activities vary across industries. And so we really want to simplify that experience per each industry to make it easier for customers to get into the platform to actually start calculating their footprint. So once they've gone through that first time setup, we can do things like calculating our carbon emissions. We have over 130 calculation methods in our platform. And this really helps our customers calculate their footprint and takes off some of that load of trying to figure out some of the complex frameworks that are out there and how to build that, and gets people out of the spreadsheet mode. Ultimately, we need to tie these things to real physical assets, such as locations, facilities, other types of assets that are actually producing those carbon emissions. And so we really help you manage those parts of your data as well. Now, given that you've calculated that footprint, the next thing that customers always want to do is they want to analyze and track. They want to see what parts of their footprint have the biggest emissions footprint. Where could they actually go after reductions of that? And so things like our Explore footprint and ultimately our Reduce footprint allow people to gain those insights into, I can clearly see these are my most emitting types of activities, and if I reduce them by 10%, this is the impact I could have on actually reducing our carbon footprint. Of course, once you've done that, many people want to commit to a target. You know, we talked about being net zero by 2040, so people want to set science-based targets and then actively track their activities towards that. And so we have our climate trajectory modeling add-on that allows customers to do just that. Of course, companies not only want to do that, but they want to compare themselves and benchmark themselves against industry peers. And so we have our climate impact benchmarking add-on, which facilitates that concern. It also allows things like our portfolio managers and our financial service companies to take a look across their portfolio and compare to companies there to decide where investments should be made on companies that are actually actively addressing their own footprints, and make some of those decisions there based off of companies that will have the best impact on climate. Of course, all of this leads to actually operationalizing this and making a real impact. Again, making those hard choices about how do we reduce our strategy or reduce our footprint overall. All right, so going to get more into the technology section. So the architecture challenge, as it really is for most startups, is to innovate at warp speed. Yet, within a climate technology startup, that need for innovation is even faster. The time to act is now, and with increased action on regulatory and financial fronts, the appetite for our product is very, very real and tangible. One thing to realize is that climate management accounting platforms did not even really exist a few years ago. We're not talking about accounting standards that have existed for decades, that are fairly slow changing and very well defined, that maybe have a little bit of tweaking from year to year. No, we're talking about standards and frameworks and regulations that have just coming into being and getting changed and defined even as we speak. So we often talk about this problem as we are literally building the plane as we're flying it. And not only are we trying to hit this moving target, but we still have to achieve all the normal building enterprise software concerns, things like setting up SSO and things like making sure that the data is secure, and all of these challenges that just any startup faces as they're building a new product. So the challenge is very real for us as we're building this thing. Now, because of this appetite and because of our diverse customer base across all industries and leverage across the globe, we really have to make sure that our platform is secure, it's scalable, and it's stable at everything we actually build. Much like AWS, we emphasize and stress that our #1 engineering principle is security. And when you work with financial institutions and banks, all of it has to be very, very secure. Additionally, we are rapidly onboarding customers, with customer growth tripling since we engaged with AWS Data Lab earlier this year. With increased customer growth, of course, comes increased data volume, as well as a variety of customer experiences and needs. Ultimately, the heart of our application is a data-intensive application. And so I want to break that down, what it really means from probably a very real-world example. So at this conference, I've heard numbers of around 50,000 to maybe 80,000 attendees. If you think about it, most of us probably got here by plane. And so that's 50,000 to 80,000 flights. And then we're all going to obviously go back home by plane, another 50,000 to 80,000 flights. So if we just take that low number, that is 100,000 carbon-emitting activities just for those 2 flights, just for this one conference alone. So you can see the volume that exists in all the types of things that we do in carbon. Now, let's break it down a little bit further, because those flights are not necessarily all same or uniform, right? We each had different distances we traveled, different types of planes that we flew on, different types of fuel that may have been used within those planes. So part of the thing that Persephone really simplifies is to take all of those variables, allow customers to input just what they needed to, such as distance, and actually calculate that for those 100,000, 160,000 types of events and get it into our platform as rapidly as possible. You know, another maybe concrete example that we could relate to as perhaps technologists in this room is we all use technology and infrastructure. And so the choices that we make actually has an impact on carbon footprints as well. You know, what type of processors do we use? Where do we actually host and store our data? Are we leveraging all of AWS's services that are sustainable and working in very energy efficient data centers? Or, heaven forbid, are we still using kind of legacy data centers with legacy hardware that's very inefficient and those types of things, right? So all of these are choices that we make and then ultimately we capture and visualize for people within our platform. Of course, to do all this, we actually have to grow our engineering staff. And so within the last year, we've grown that engineering staff significantly by over 50%, and just in our R&D environment alone. And so that really helps us facilitate all of these concerns. But at the same time, it creates new technical challenges. Things like data collisions, things like defining clear and defined software and architectural boundaries, making sure that we can deliver features independently. And so a lot of what we'll talk about going from this point forward is how we've addressed some of those things as we're building this platform. So if you take a look at it first, this simplified monolithic architecture was what we were running at the beginning of the year. And it makes a lot of sense for a startup at the early points of its stage to have an architecture like this. Most of the services that you'll see here are pretty bread and butter for building a modern SaaS platform. You have Amazon Route 53, talking to your load balancer, ultimately talking to containerized services and storing that data in Aurora S3 and storing semi-structured data, storing data in Aurora MySQL and semi-structured data in S3. Now, what you also see here is that we have very tight coupling with both our API layer and our data processing layer. This is very problematic, and so the first thing we really wanted to do is actually figure out how do we scale these things independently? How do we break them up so that they're running in their own containers independently from each other? And so this was the first challenge that we wanted to tackle because, again, our data processing is the key thing. Getting data into the system is very, very important because you can't handle 100,000 events, nor do you want to scale your API, which is not doing the same thing as your data processing bulk editing layer to get that data into it. And so things like scaling horizontally and scaling vertically of the processes that matter were key to how we wanted to think about our future state architecture. One of the challenges that you immediately figure out when you start thinking about going from a monolith to microservices is where are your cross-cutting concerns and which of those cross-cutting concerns are the most important to break up immediately. And so we realized very quickly that authentication and authorization that were so tightly coupled in the monolith were something that we had to take out and move immediately if we were going to have better independent delivery and better independent services. And so that is one of the things that we'll discuss here in just a second. The next challenge was, how do you build an architecture that would work across different languages and support ML inference? You know, as a startup, we've got to move very quickly. We've got to innovate at warp speed. And so if you introduce a lot of new technologies and figure out how to get them into your architecture, that actually increases your technical complexity. One of the things we wanted to do was leverage the same architecture, but leverage it for ML inference services. Most of our APIs are built on Go. As many of you know, Go is not necessarily the best language for machine learning inference services. Most data scientists, most ML engineers, they want to build in Python. But when you have a monolith built in Go, that's going to be preventing you from that type of strategy. So again, one of the things we were trying to address as we built this new architecture. And then finally, as you can imagine, a monolith ultimately prevents independent delivery. You have code collisions, you have high risk, because you have all of the code being deployed at the same time by growing engineering teams, and makes more and more difficulty to actually move forward. So how do we break these things up? How do we deploy independently? All concerns we wanted to address as we thought about moving from a monolith to a microservices architecture. So we embarked on a journey, and it's really a journey we are still on. You know, the journey from monolith to microservices is somewhat of a long journey. Now, the first challenge we had to make was going through the deep technical decision process of where we would put each concern. So which concerns live at the software layer? Which concerns live at the infrastructure layer? How are we going to do things like independent delivery? How will we structure our code bases and our CI/CD pipelines? And all of those types of activities. This is where our work with AWS really started to kick off. We leveraged AWS Data Labs to help us think through this design that you have pictured here and come up with this approach. You know, while I was at AWS, I actually had the benefit of working on a number of AWS Data Labs and saw how this impacted customers to really propel them forward in an actionable way. As technologists, a lot of times, and particularly at a startup, we have so many things going on that it is rare that we actually get to all sit in a room alongside our AWS partners and come together for a couple of days, brainstorm, discuss our current architecture, discuss our desired target state, and actually come up with a proposed architecture on what we would like this thing to be. But that is exactly what you do in a design lab. We had 2 days where we brought our cloud architecture team, our engineers, the product architecture team, and AWS solution architects who are experts in building a microservices architecture to the table. And after we came out from that, we had a full design report that specified the architecture that you see here based off of all of those needs and those pain points that I've been discussing. Once we got out of design lab, in just a couple of weeks, we then started a build lab. And in the build lab, we do just that. But now we're spending 4 days, again, a very rare opportunity to bring all these people together in a focused mode and work together to see this through, taking our existing code base, breaking things up, putting them in the right spot, testing it out with the AWS services that we've augmented, and then ultimately figuring out how are we going to take this and build it as infrastructure as code, take it from a sandbox mode to the development environment and the production environment. You know, I think another key benefit that is sometimes lost is that the build labs are great, but the challenge to actually get it deployed to production has its own implications, right? We cannot just stop the delivery teams from continuing to build new products and features. And so we also worked with AWS to design an effective cutover strategy that did not impact those product delivery teams and still allowed us to cut over safely to this architecture. And so you can see how this architecture is starting to play out. So we've introduced new things like Amazon API Gateway. We have a Lambda custom authorizer. In our container layer in Fargate, you start to see the breakout of services. We've got a platform API service that hosts our current monolith. You've got an authorization service that we have broken out as one of our key layers. And you've got job services that are now able to scale independently, both horizontally and vertically, based off the load that we have at any given time for data ingestion that we are bringing into the system. And so that was one exciting byproduct that we had. And as you can see, again, we were able to separate out that authentication service. By separating out that authentication service, it allowed us to do really cool things. Back to that problem I mentioned earlier. I want inference services to work within this architecture, but I can't have them built in Go. But because of this architecture, because we moved authorization and authentication out, now I can have authenticated the exact same way, still as secure as we need, to build those inference services in Python, running the machine learning, building out cool capabilities for our customer base. So that was a really exciting byproduct of this architecture. And I mentioned earlier, we work with financial services. And while we had encrypted in transit and encrypted at rest, at our storage layer, communication layer, one of the things was we wanted to use mutual TLS between these microservices. One of the technologies introduced by AWS was the app mesh technology. And this really allows for that mutual TLS scenario and security between service-to-service communication. And so things like, how does the monolith talk to the new ML inference service? We can allow communication between those two and make sure that is fully encrypted as well. Of course, we're at a startup, so this is not the only problem that we're solving, right? So one of the other challenges that we are facing, even as we are building the microservices, is how do we scale globally? And how does this architecture work across multiple AWS regions? So at the same time we're building this out, we're figuring out that problem as well, because we want to store carbon emissions both in Japan, both in Europe, both in America. And all of these locations are areas that we have customers. And those customers ultimately have operations across the globe as well. And so often you want to see those same results and same climate activities that are captured in Japan very quickly in North America as well. How do you build out that style architecture? And so ultimately, we went into another data lab. And from that data lab, we had great discussions on how do we do this with Amazon Aurora Global Databases. And we landed on Amazon Aurora Global Databases because ultimately, it simplified that operational layer and keeps that data in sync in near seconds as it does things like block-level replication across the AWS global backbone. And so this really simplifies that replication and keeping it in sync for us, better than what we were seeing with things like bin-level, row-level replication as well. Now, we still wanted some of that row-level replication because we ultimately want to sync that data to our data analytics layer in near real time as well. And so we were able to leverage AWS MSK, Managed Streaming Kafka, for faster insights. So enabling microservices really has opened a lot of doors for us. Since we've introduced microservices, I've already kind of hinted at some of the ML inference services, but we continue to build on those inference services. How do we build better recommendation engines for getting data into the platform? How do we have insights as far as where the data anomalies are so that we can tell people, hey, things like you have missed these months, or this month is abnormally high. Was this high quality data? Was this an abnormal event? Or, is this fully expected? All of those types of capabilities we are building as we continue to leverage. And now that we have this microservices architecture, we can continue to create new ML inference service after new ML inference service. So pretty exciting stuff. Now, not only are we doing that, but we are working towards more feature-based CI/CD practices. We want those code teams to be able to develop and to work independently of each other without having those collisions, without having that high risk. So that is a continued ongoing effort that we're doing. Of course, as I mentioned, we weren't stopping the ship as we were building it. So we continue to deliver and create brand new capabilities and simplify the flow with things like our new CMAP 2.0, which really simplifies that user experience. And so it's been important for us to build this architecture, build on top of this architecture with not impacting new product feature delivery. And we continue to release feature after feature, and we'll continue to do so to benefit our customers. Of course, ultimately, we need to go through that decomposition strategy. And so we think through things like how do we do more domain-based services? How do we create net new microservices repeatably, leveraging this pattern that we've defined? And going through that hard activity of actually doing the decomposition of the monolith, an activity that will carry on into 2023. So, yes, we deeply believe in the old adage of what gets measured gets managed. Over the past year and a half, the carbon activities we are measuring has increased exponentially, and we now manage 7.2 billion metric tons of carbon. The goal of that management, ultimately, is to help our customers find ways to reduce that carbon footprint and to set targets and to meet those targets. And so we'll continue to work with our customers, we'll continue to work with our partners AWS to reach that climate journey and work with all of you to tackle this problem heads on. You know, in this room, we have a lot of people passionate about climate. We have a lot of people passionate about technology. You know, for me, this is the great thing about being at a company like Persephone. Data is at the heart of everything we do. And my role is really to help build these amazing products that have a climate impact. There is nothing cooler than seeing our customers embrace our product, solve difficult architectural challenges, and realize that we're making a direct impact for people like my kids, for you all, for everyone else as we build this thing. That is really great and really fun. A lot of times, as a technologist, we get to play with cool technology. Sometimes we get to solve really cool problems that make a very meaningful impact on the world. And so that is the joy of working at Persephone. You know, one of the things I think that's important to know is you don't actually have to have a climate analytics background to be able to work at Persephone. You know, we need all types of roles, whether it's software engineers or data engineers or cloud architects, product managers. So very technical roles can come without a climate background and actually make a real impact by applying skills that they've honed and built over years. And so definitely would encourage all of you to talk to me afterwards if you have any interest in that, and we can talk about that. So I want to thank you for being here. And Michael and I will be here afterwards to take any questions off stage. And thank you again for your time today.